Hello and welcome to this lesson about angle-angle similarity. The learning target of this video is to determine if triangles are similar, or being able to determine if they are similar, and then to use properties of similarity to solve problems with triangles. So here's the theorem. This is what everything is about right here. Now keep in mind, a theorem is a concrete statement that we know something about in math. And the theorem we're going to look at today is that if two angles of one triangle are congruent to two angles in another triangle, the triangles are, use a different color here, similar. All right, now what I want you to think of when we say this theorem and we kind of talk about it more is I want you to think of siblings that look alike that aren't twins. So think about siblings who are maybe a couple of years apart from each other, yet they look very, very similar. Or if you were to take a look at the picture of the older sibling when they were the same age as the younger sibling, they look like identical twins. That's sort of what we have with similar triangles. Similar triangles aren't exactly the same, but they're going to be similar because they share at least two angles. And by the time you share two angles, you have to share that third angle as well. And so that is what similar triangles are, and this is sort of the big rule. And so again, what does it mean? It means that similar triangles are proportional. So let's take a look at a simple example. Something we'll learn about a little bit later is a triangle called the 3, 4, 5. Well, if there's another triangle that's similar to it, has the exact same angle measures as this one, so it's supposed to be a right angle there, and they got another angle there. And let's say this is 9. This is going to be proportional. So in order to go from 3 to 9, we times it by 3. Well, we'll do the same thing here to get 12, and the same thing here to get 15. We can take any ratio of the sides, and they got to be equal to each other. So if we did 15 over 5, that's got to be the same as 12 over 4. So similar triangles are proportional. And what that does is it helps us with a couple of things. One, we might have to find a missing side length. We might not be given that this is 15. We have to find out that it is 15. So you can set up a proportion to do that. Two, if things are proportional, you've proven that they are similar. And so let's talk about what it is you're going to be expected to do. There are two things I'm going to be looking for you to do. One, determine if triangles are similar. Again, there's two ways to do that. We'll talk about that in a second. Second thing I'm going to be expecting from you is to find a missing side length. So those are the two things you're going to have to do, and it all hinges on the idea of two angles being congruent to each other in two different triangles. It means that they are similar, that their sides are ratios and proportions to each other. And so let's kind of walk through some examples of what this is going to look like. All right, so let's say here, the question is, are these triangles similar? So we have two triangles, not necessarily drawn to scale. This one's 75 degrees and 80 degrees. This one is 80 degrees and 25 degrees. So far, they have one condition of similarity in that they both share an angle measure of 80 degrees. But we need to see if they have another angle measure that's the same. And right now, we don't see that. We see a 75, we see 25. So what we have to do first is find out what is this angle measure going to be. And so what we'll do is go 75 plus 80 which is 155, and then go 180 minus 155, and that gives us 25. Well, right now, we're done. Like these angles, we have two that are similar, 25, 25, 80, 80. So yes, they are similar to each other. All right, let's do another example. So again, the question is, are they similar? And this time, we're going to go with side lengths. So 7, 9, and 4 for the first triangle, 14, 18, and 6 for the second triangle. Now, what we're going to see here is we have to find the corresponding side lengths. And when I mean corresponding, I'm talking about, we sort of have the smallest, the medium, and the largest. The small, the medium, the large. And so when we set these proportions, we have to make sure they're all the same. And so the best way to maybe do it is just to kind of go, the ratio of the large ones has to equal the ratio of the medium ones, which have to equal the ratio of the small ones. And what I mean by that is I'm going to take 18 and I'm going to put it over the other large one, which is 9. I've made a ratio. Now, at this point, we're kind of dealing with that unofficial math symbol of the question mark equal sign, where are these equal to each other? So 14 over 7, and then 6 over 4. So these two work out. They both reduce to be 2. This one, however, is 1.5. Since that's not proportional to these guys, these triangles are not similar. So the answer to this one is no, or not similar. And so those are the two ways you can determine if a triangle is similar. One, you have to look at the angles, and you're looking for two angles, 25, 25, 80, 80. And if we did the same process of finding the missing angle here, you would find 75, and again, you'd be fine. So yes, those are similar. Or you could have side lengths and try to determine if they're similar. And all of them have to be the same. And I recommend going with this large, medium, small sort of approach, setting them up. That way you keep everything nice and organized. Finally, the other example I have for you is how to use this. Finding a missing side length. And this one, fairly straightforward. So let's just do a couple of things. Let's just say we have some right triangles, where the height on this one's 5, and this one faces 12, and then we have another one, and we're told that these are similar. So, it's given they're similar. Now the prompt is find x, find the missing height. So what we'll do is we'll set up a proportion. Now I drew these triangles nicely so that they are both facing the same direction. So I could do it however I want, just as long as I'm consistent. Again, maybe if we kind of go with that large equals small thing, or medium, whatever you want to call it, could work out well. So the large one is 60 over 12 is equal to x over 5. I set up a proportion that is has the two longer bases on the left-hand side and the two shorter bases on the right-hand side, and I have the bigger triangle in the numerator, the smaller triangle in the denominator. Another way I could have set this one up, I could have gone 5 over 12 is equal to x over 60, where I just take the small over the large of one triangle equal to the small over the large of another triangle. Either way, we have to do a little cross multiplication and solving, or in this case, just leave the 12 here. This becomes 5 equals x over 5, and then I times both sides by 5, x equals 25. I'll get the same thing here. So here I actually do have to do a little cross multiplication. Or again, I could just move the 60 over because I'll have to divide by 12 anyway. So I'll have 60 times 5 over 12 is equal to x. But then 60 and 12 becomes 5. And x still equals 25. So now that's it with right triangles. For good measure, we'll do one more. Okay, so I've got another example here. This time it's not with the right triangle, but we are told that these two triangles are similar. Okay? I mean, you're going to be given this. You're not going to have to first find it. It's going to be, these are similar triangles. Now find the missing side length. What's different about this one is I've included this little thing. And this is supposed to be like, hey, these are some of the angles that they have in common. So what we're going to have to do is a little flippy flip of this triangle, if you will, to make it look more like this. So I'm just rotating it kind of like I'm putting a pin on it here, and I'm flipping this guy over there. So now that's there. This is still 24. The x travels over here, and we get an x there. When setting up the proportion, it's just all about being consistent. As long as you're consistent, you're fine. And so here we have the base. Maybe I'll go 8 over 24, so I'm going from the left to the right. And so I'm going to have 14 over x. All right, if you wanted to, again, you could go with like just one triangle. 14 over 8 is equal to x over 24. Either way, it's going to work out just fine. Now, go about solving. So here, do a little cross multiplication. We'll end up getting 8x is equal to 24 times 14. I'm not multiplying that out because I have to divide by 8. And I know when I divide by 8, that's going to become 3. X equals 3 times 14, which is 42. Here, I'm going to get something similar. Divide both, or multiply both sides by 24. And so I'll have, again, 3 over 1. 42 is equal to x, and there we go. So, quick recap. First thing, if we have two congruent, that's the fancy math symbol for that, angles in two triangles, they are similar. And if triangles are similar, that means that they are proportional. Proportional, meaning that we can take a ratio of components of them and set it equal to the ratio of components of the other triangle, or we can do, the longer sides and the medium sides and the smaller sides, and we could use proportional to determine if something is similar. And then you just have to use a little cross multiplication to solve for any missing side links. So good luck with your homework, and if you have any questions, please let me know.